Hello dear friends, welcome back to MACSGATE. Dear Mokshit Patel, very good evening. Welcome to the session. So those who are attending the session, you can tell your presence, okay? Mark your presence by saying something in the chat box, right? So in the last class we started with the probability, okay? I just introduced the basic terminology. What is probability, okay, and we also try to understand some very basic level problems, okay, and I also given two problems as homework and I asked you to try them. So first let me quickly solve those problems and then we move on to today's session, right? This was the question which I given. In a population of n families, 50% of families are having 3 children, 30% families are having 2 children, and the remaining families have 1 child. What is the probability that a randomly picked child belongs to a family of 2 children? See, very common mistake for this particular problem which people do is, okay, what is the probability that a randomly picked child belongs to a family of 2 children when it is asked? So what they think is 50% are having 3 children, 30% are having 2 children, remaining means 20% are having 1 children. So total 100%, 30 are having 2 children. They feel that 30 by 100, that is 3 by 10 is the answer. So this is a very common mistake which is a blunder. So for this I always ask student one question. Here, have you picked a family at random or you picked a child at random? See, directly I can give you the answer, but please try to understand, analyze the question. Then you can answer next problem on your own. See, the agenda is not me going and solving the problem, sir. You need to go and solve the problem. So I want you to read the question carefully. Here, what is the probability that a randomly picked child belongs to a family with 2 children? That is, we picked a child at random, not family at random. Suppose the question is, what is the probability that a randomly picked family, or suppose that you picked a family at random, what is the probability that the family is having 2 children? Then 3 by 10 is the answer. That is, a family is picked at random. Then what is the probability that the family is having 2 children? Suppose this is your question, then 3 by 10 is the answer for this. But the question is not that. Just try to understand this. Okay, please read the questions carefully. That's why I always tell people, try to take a book or try to select questions which are non-ambiguous. Okay, then you will not have such kind of troubles. Sometimes I also seen people like ask this question and they answer different thing as the answer for that problem. So you need to be very careful when you pick the questions, and once you pick the questions also read them carefully. What is asked, understand, then answer. Here we picked a child at random, not a family at random. See, for this problem 3 by 10 is the answer, but for the given problem 3 by 10 is not the answer. Please make a note of it. Okay, so here we are having, we do not know, he mentioned that there are n families. For simplicity, let us take this n as 100. You can work with n also, but for simplicity, I take n as 100. 50% families are having 3 children. So 50% of this means 50 families. Each family is having 3 children. One family having 3 children means 50 families are having how many children? 50 into 3, that is 150 children. That is, in these 50 families, we are having 150 children. The next 30% means 30 families. Each family having 2 children, then 30 families having how many children? 30 into 2, that is 60 children. The remaining 20%. 20% of 100 is 20 families. Each family having 1 child. Then 20 families are having how many children? 20 children. So then total number of children will be, what about total children here? Total children is 150 plus 60 plus 20, that is 230 children. This is total number of children. Out of this 230 children, we are picking, okay, a child at random. We are picking a child at random. Now you need to tell what is the probability that the child belongs to family with 2 children. What is the probability that the child belongs to family with 2 children? So this is your question. What is the probability that the child belongs to family with 2 children? So total, you can just write down the formula also if you want. What is the formula? Favorable number of cases by total number of cases. Total how many? There are 230 children. Favorable how many children? 60 children favoring this particular condition. That is 60 children belongs to family with 2 children. Clear? So what is the probability for this? 6 by 23. So the correct answer for this is 6 by 23, not 3 by 10. Please make a note. Please note this, my dear friends. Hope you all understood. And I also asked one more question here. What is the probability that the randomly picked child belongs to family with 1 children? Okay, 1 child. So here same thing, total is 230 children. And how many children belongs to family with 1 children? 20. That is favorable. So what is the probability that the child belongs to family with 1 child or 1 children? So what is it? Favorable, that is 20 upon total, that is 230, which is 2 by 23. Is that clear? The next one. What is the probability that the child belongs to family with 3 children? Okay, so what is it? Here total is 230 and favorable. This is favorable, 150, because there are 50 families, assuming 100 families total. So 50 families, each family having 3 children, so total is 150. So these 150 children are favorable for this. So what is the probability that the child belongs to family with 3 children? So that is 150 upon 230, which is nothing but 15 by 20. Is the idea clear, Babu? All of you able to follow? Right. I asked one more question. A fair coin is tossed n times. What is the probability that the difference between number of heads and number of tails is n minus 3? So here I'll give you 2 methods. First method. So when you toss a coin, you will be having head and tail. These are the possibilities. Suppose you toss it n times. If you toss it n times, it may be possible that you may get n heads and 0 tails. Or you may get n minus 1 heads and 1 tail. Or you may have n minus 2 heads and 2 tails. These are the possibilities. Or you may get 1 head and n minus 1 tail. Or you may get 0 heads or n tails. So what is the difference between heads and tails? Here it is n. Here it is n minus 1 minus 1, that is n minus 2. It is n minus 2 minus 2, that is n minus 4. 1 minus n minus 1, that is 1 cancel. You get, I think, 1 minus of minus plus. So 2 minus n, and it is minus n. See, if you observe, we never get the difference between head and tails equal to n minus 3. So this case never arises. The case that the difference between number of heads and number of tails n minus 3 never arises. So this is an impossible event. This is an impossible event. When you toss a coin n times, probability of getting difference between number of heads and number of tails n minus 3 never arises. Am I clear? So what is the answer for this problem, my dear friends? What is the probability that the difference is n minus 3? It is 0, because it is impossible event. Because it is an impossible event. There's one more way you can do it. This is the first method. You can try one more method where, see, it's like this. Suppose number of heads is equal to x, then number of tails will be, because total n coins, you are having n tosses. Out of that, x are heads means n minus x are tails. So what is the difference between heads and tails? that is x minus n minus x, that is x minus of n minus x. So you are going to get 2x minus n. But this difference you want it to be n minus 3. This difference you want it to be n minus 3. You can make this way. Of course, this also fine, but let us make this as like this. X heads, then n minus x tails. See, the calculations are simple. That's why I'm doing it. So what happens? Heads minus tails will be n minus x, that is n minus 2x. So here n get cancelled, and minus 2x is minus 3, that means 2x is 3. What does it mean? X is equal to 3 by 2. Can you have number of tails 3 by 2? See, because that number of tails or number of heads must be integer. Okay, it should be actually positive integer, but you got 3 by 2 fraction, which is not possible. Therefore, the event is impossible event. This event is impossible event. Am I clear? Right. So now today's session, the main agenda is combinatorial probability. So don't worry about this terminology, sir. Combinatorial probability. Probability using counting techniques. See, this combinatorics is nothing but counting techniques. The study of counting techniques is what is called as combinatorics. Combinatorial probability means probability, the study of probability using counting techniques. See here what we are interested, sir, we are interested in finding probability of event. So now we want to find probability of events using counting techniques. So far how we are finding probabilities, Babu? So far we are finding probabilities directly by listing the elements, by observations we are doing it. Now we try to use some counting techniques. Let me quickly introduce the basic counting principles, then we move on to the permutations and combinations, the result, and how we can use those results for solving probability problems. Okay, so I try to do it in 2 days. Today we will try to handle this permutations and combinations without repetitions. Tomorrow the remaining part we try to continue, right? So basic counting technique starts with this addition and multiplication rules. I just quickly give you the idea of addition and multiplication rules, because the basic rules of probability and combinations are obtained using these principles only. So one need to understand them. So the addition theorem, I'll just give you simple idea. For example, we are having say 4 discrete mathematics books, 3 data structures books, and 5 algorithm books. Now I ask you one question. Number of ways we can select one book. How many ways you can select one book? So how many ways you can select one book, sir? You can select any one of the discrete mathematics book. You can select any one of the data structuring book. You can select any one of the algorithm books. So the number of ways you can select one book is nothing but 4 plus 3 plus 5. So we can select one book in 12 ways. See, this is what we call it as addition rule, addition principle. Okay. So the idea of addition principle or addition rule is this. If event 1 can happen in m ways, event 2 can happen in n ways, then E1 or E2 can happen in how many ways? M plus n ways. But here we need to understand one very important thing. When you are saying event 1 and event 2, we are assuming that the 2 events are mutually exclusive. See, later on we are going to talk about this addition theorem of probability. There this idea is very, very important. Okay, the 2 events are mutually exclusive. So if an event E1 can happen in m ways, event E2 can happen in n ways, and E1 and E2 are mutually exclusive or disjoint, then E1 or E2 can happen in m plus n ways. That is what you call it as addition theorem or addition principle or addition rule in short. Let us take one more question. This is my first question. Now consider the following question. Suppose you are having same discrete mathematics books 4, data structuring books 3 and algorithm books 5. Now the question is, how many ways we can select one book from each category? How many ways you can select one book from each category? So here there are 4 ways of selecting discrete mathematics books. For each of these 4 ways, there are 3 ways of selecting data structuring book, and for each of these 4 into 3 ways, there are 5 ways of selecting algorithm books. So the number of ways we can select one book of each category is given by 4 3 is 12, 12 5 60 ways. So totally we are having 60 cases. So this is what we call it as multiplication principle, my dear friends. So what is this multiplication principle or multiplication rule? If event E1 can happen in m ways, event E2 can happen in n ways, okay, and the number of ways E1 followed by E2 can happen. The number of ways E1 followed by E2 can happen. How many ways E1 followed by E2 can happen? And that is given by m into n. And here one important thing is, the events must be independent events. The events must be independent events. Suppose if I put a rule like, if you select, suppose Rosen book, one of the discrete mathematics books, then you are not allowed to select Corman book, okay, and Horowitz data structuring book. Suppose if I put such condition, this number of ways cannot be 60. So in such cases, the problem or the event becomes dependent events. See, when event becomes dependent, the story becomes little difficult. We need to analyze the situation and accordingly we need to solve it. So we try to understand these ideas when you talk about conditional probability and multiplication theorem. There the idea of independent and dependent events plays very important role. Okay, please try to understand. See, when events are happened simultaneously, then there is a chance that some of the outcomes are common between them. Then they becomes, okay, non-disjoint events. But when events are happening at a time simultaneously, if there are no outcomes in common, such events are called mutually exclusive events. In such cases, generally we talk about E1 or E2. And whenever they are disjoint, simply the probability of E1 or E2 is nothing but probability of E1 plus probability of E2. That is the idea when the events are mutually exclusive. We already seen under the axioms. Okay. So if you remember this, if you remember yesterday also under the axioms, the third axiom says, suppose A and B are disjoint or mutually exclusive events, then probability of A or B is simply probability of A plus probability of B. So this happens, my dear friends, when the events are disjoint. That is directly coming from addition rule. Is the idea clear? Hope you understand. Now let me take one problem. Very interesting problem. Yesterday I was telling you the importance of indirect counting. So I just thought I'll solve one problem on this indirect counting. Then we move on to the idea of permutations and combinations. Okay. Look at this question. If you want, you can try this, my dear friends. You can try to get the answer for this problem. Very simple question. A non-negative integer less than 10 power 3 is selected at random. What is the probability that it contains the digit 1? What is the probability that it contains the digit 1? See, my dear friends, if you want non-negative integer less than 10 cube, you can try to answer this logically. For example, I'll ask you one question. Okay, for those who do not know what are the non-negative integers, let me tell you that also. Non-negative means not negative. That is positive including 0, because 0 is neither negative nor positive. Non-negative means these numbers 1, 0, 1, 2, 3, 4 and so on. Now I want non-negative integers less than 10 power 3. Instead of solving that big question, complicated question, let me take a simple question here. How many non-negative integers less than 5 are there? How many non-negative integers less than 5 are there? Let me count. 0, 1, 2, 3, 4. How many are there? 5. So generalize and answer. How many non-negative integers less than 10 power 3 are there? You don't need to count here. I just generalize the idea. So how many are there? 10 power 3 are there. That is 1000 such fellows are there. But this method doesn't work to answer this question. So I need a logical method. Okay, of course I just use a common sense idea for this, but I need a method, okay, analytical method, where I can use the formula or this multiplication principle, whatever it is, to get the answer. See, if you want non-negative integer less than 10 power 3, 10 power 3 means 4-digit number. Less than 10 power 3 means it is maximum 3-digit number. Maximum 3-digit number. So if you want non-negative integer less than 10 power 3 means you want 3-digit number, 2-digit number, 1-digit number. So you can count how many 3-digit numbers are there, how many 2-digit numbers are there, how many 1-digit numbers are there, add them to get the total non-negative integers less than 10 power 3. How many 3-digit numbers are there? How many 3-digit numbers are there? This is 3-digit, this is 2-digit, and this is 1-digit. So here what I can do, sir? 3-digit means the leading digit cannot be 0. So there are 9 possibilities. Because there is no restriction on repetition of digits, so there are 10 possibilities here. Here you can keep any of the 10 digits. You can keep 0, you can keep 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are totally 900 3-digit numbers are there. Then how many 2-digit numbers are there? 9 possibilities, 0 cannot be here. Then 10 possibilities, 90 2-digit numbers. How many 1-digit numbers? See, 1-digit number, 0 also considered as 1-digit number, because we are interested in non-negative integers. So total 10 are there. So total 1000 such fellows are there. Or I use one more logical idea here. This is a long method. Let me use a simple logical idea here. See, I am looking for maximum 3-digit number. Maximum 3-digit number. See, if I use 9 choices for the first digit, I get 3-digit number. But if I use the 10th choice, that is 0 also allowed, by allowing leading zeros, that 3-digit number become 2-digit, yeah, 1-digit number also. So that is the logic I am using, my dear friends. So by allowing leading zeros, the 3-digit number becomes 2-digit and 1-digit also. That is, we get all 3-digit, 2-digit and 1-digit numbers. So here I am having 10 choices. With 9 choices, I get all the 3-digit numbers. With the 10th choice, that is with leading 0, I can also get 2-digit number and 1-digit number also. That is the logic. And here there are 10 choices. Here there are 10 choices. So total, what is the answer? 10 cube. See, same question I answered in 3 ways. One is common sense method. How many non-negative integers less than 5 are there? I know 5. So similarly, number of non-negative integers 10 power 3 will be 10 power 3. The second method is finding all 3-digit number, 2-digit number and 1-digit number, adding that. And the more interesting method is this one. By allowing leading zeros, I can make this number 3-digit, 2-digit and 1-digit. So I know total number. This is total, sir. This is total number of cases. So total number of non-negative integers less than 10 power 3 is 10 power 3. But what is the question? If you select one of these number, what is the probability that it contains the digit 1? What is the probability that it contains the digit 1? See, it contains the digit 1 means there is a problem here. See, contains the digit 1 means what? Contain digit 1 means what? Suppose if it is one digit number, contain digit one time. Suppose if it is a two digit number, it may contain one time, or it may contain one two times also. So you need to consider all the three cases. Suppose if it is a three digit number, it may contain digit one time in any of the places, or it may contain digit 1. See, I said contain the digit 1, but how many times is not mentioned. So contain 1 2 times, so you need to consider all these cases, or contain 1 3 times. See, this many cases I need to solve if you need to solve this problem directly. Suppose if you solve this problem directly, you need to consider this many cases. It's not that impossible, sir. This is the idea. But if I solve this, I want it should contain the digit 1. What I do is I find how many non-negative integers less than 10 power 3 does not contain digit 1. That means digit 1 is not at all used. So if it does not contain digit 1 means what? So for this there are 9 choices, because earlier 10 digits are there, but now 1 is not used. Only 9 digits are used. By allowing leading 0, so there are 9 choices here, there are 9 choices here, there are 9 choices here, total 9 cube. So how many does not contain the digit 1? 9 cube. Now if I want how many contain the digit 1? How many contain the digit 1? Total minus do not contain digit 1. That is 10 cube minus 9 cube. Okay, or you can do one thing. You can find probability that they do not contain digit 1. They do not contain digit 1. So do not contain digit 1 means 9 cube favorable out of 10 cube. 9 cube is favorable, total is 10 cube. But if you want contain digit 1, contain digit 1, how can you solve it? Contain digit 1, how can you solve it? 1 minus do not contain digit 1. I am simply writing do not contain 1. So it is 1 minus 9 cube by 10 cube. And that is the answer, which is nothing but 10 cube minus 9 cube by 10 cube. 10 cube is 1000, 9 cube is 9 9s 81, 9 8 729. 729 by 1000. So how much is this, sir? 1000 minus 729 means 200, 281 I think. Please check, sir. So it should be 0.281. Please verify that, sir. Okay. So that is how we handle such problems, my dear friends. So this is the importance of indirect counting, which I was mentioning yesterday. Is the idea clear? Clear? And here we actually use this multiplication principle. We actually use this multiplication principle. Hope you understand. Now let us move on to the concept of permutations and combinations. See, the idea of permutations and combinations is very simple, sir. Suppose you are having, say, 10 books, and suppose you are having a rack which can accommodate, say, 6 books. So in the rack you can only keep 6 books. So we are having 10 books, but you are having a rack which can only accommodate 6 books. What we need to do, sir? So first thing we need to do is we have to select 6 books. Then the selected 6 books need to be arranged in the rank. That is, arrange 6 books in the rack. So here the process of selection is what is called as combination. The process of selection is what is known as combination. And the entire process of selection followed by arrangement is called permutation. See, some people confuse here. They feel that permutation means just arrangement. No. Selection followed by arrangement is permutation. Combination is selection, whereas permutation is selection followed by arrangement is permutation. Hope you understand. Is the idea clear? Like that. So here this combination, what is the answer? Out of 10, I am selecting 6 books. Whereas this permutation, out of 10, I am permuting 6 books. That is selecting 6 books and arranging 6 books. That is what we call it as permutation. Of course, we are having formulas for permutations and combinations, sir. Okay. So the basic formula is like this. Suppose you are having n object. NPR denotes R permutation of n objects. R arrangement, this entire process, R arrangement of n objects. And that is given by the formula n factorial by n minus R factorial. That is R permutation of n objects is given by n factorial by n minus R factorial. So here number of ways of arranging 6 books, okay, out of 10 books in a rack is given by 10p6. So what is the answer for this? 10 factorial by 10 minus 6. 10 minus 6 is how much, sir? 4 factorial. If you simplify, you get the required answer. And number of R combinations of n objects. Number of ways of selecting R objects out of n objects is given by the formula n factorial by R factorial into n minus R factorial. So that is NCR. Actually, if you see this NPR here, if you take NCR and if you multiply R factorial, you are going to get NPR. That is this NCR, if you multiply with R factorial, you are going to get NPR. So here it is selection followed by arrangement. Selection followed by arrangement. So that is your combination form, permutation formula. NPR means selection followed by arrangement. So this arrangement of 6 books is nothing but 6 factorial ways you can arrange. 6 books can be arranged in 6 places in 6 factorial ways. So those are the basic formulae, my dear friends. Okay. And here we are having 2 important results. Okay. And the permutations first we try to discuss. So we are actually discussing about permutations without repetitions. Permutations without repetitions. Permutations without repetitions. So here if you observe, number of linear permutations. See, by default, permutation means linear permutation. That is, we are arranging the objects in a line. So number of linear permutations of n objects, that is n objects to be arranged in n places, is given by n factorial. Actually, it is like, npn. According to the formula, it is n factorial by n minus n factorial. That is n factorial by 0 factorial. 0 factorial is 1. So the answer is n factorial. So number of linear permutations of n objects is nothing but n factorial. That is how many ways n objects can be arranged in n places. N factorial ways. Now the important thing is circular permutation. Number of circular permutations of n objects. See, the idea of circular permutation is, see, when you arrange the objects in a circle, different circular permutation becomes same permutation. For example, if you take 3 objects, say ABC, number of arrangements of these 3 objects is 3 factorial. That is 6 different ways you can arrange, like ABC, ACB, BCA, BAC, CAB, CBA. See, these are the 6 different ways of arranging these objects in a line. And if you consider these 6 they are different. You see from anywhere, sir. You see from here, you see from here, you see from here, you see from here, or you see from top angle, bottom angle, from any angle you see. These are the 6 different arrangements. But if you consider the following 3 permutations, arrange them in a circle. That is, this ABC, you arrange them in a circle. Then this BCA in a circle. Then this CAB. So when you put them in a circle, if you look from here, it is the circular permutation ABC. See, from here it may look BCA, but if you look from here, it is again ABC. And if you look from here, this is again ABC. So the 3 different linear permutations becomes one circular permutations just by changing our point of view. So whenever it is circular permutation, we have to fix our point of view. Is out of the 3 objects, we have to fix one object and arrange the remaining objects linearly. So fix this and arrange remaining linearly. BC, yeah, CB. So these are the 2 circular permutations, my dear friends. Because 3 different linear permutations becomes one circular permutation. Therefore, 6 linear permutations becomes how many circular permutations? 2 circular permutations. Actually, n linear permutation, when you are having n objects, n linear permutations gives 1 circular permutations. Therefore, n factorial linear permutations gives how many circular permutations, sir? N factorial into 1 by n, which is nothing but, what is n factorial? It can be written as n into n minus 1 factorial upon n. This n get cancelled, you are going to get n minus 1 factorial. So because of that, when you arrange the objects in a circle, the number of arrangements are not n factorial, it is n minus 1 factorial. This is mathematically, logically we can understand it like this. Whenever it is a circular permutation, logically what you can do? Fix one object, arrange remaining objects linearly. So once you fix one object, how many objects are present now? Only n minus 1. How many ways you can arrange n minus 1 objects in a line? N minus 1 factorial. And that is the answer. Is the idea clear? So that is about your circular permutations. Whenever it is circular permutations, fix one object and arrange remaining objects in a linear manner, you are going to get number of circular permutations. Is the idea clear? All of you able to follow? Got it. One second. Right? Now let us solve problems, sir. So these are some general problems which I am solving it. Here I just kept 10. Later on you can change this to any number. We try to write the general formula also. One time in GATE they also ask such general formula in examination. Okay. 10 people arranged in a row. How many people arranged in a row, sir? 10 people. So first of all, how many ways 10 people can be arranged in a row? How many ways 10 people can be arranged in a row? So let me write like this. Total. What is total? 10 people in a row. So 10 people can be arranged in a row in 10 factorial ways. So that is total number of arrangements without any condition. Without any condition, 10 people can be arranged in a row in 10 factorial ways. Now suppose if I put some condition, what is the probability with this condition? That is, what is the probability that certain pair always together? So when you say certain pair, it's like a fixed pair. That is a 2 members fixed. Let us call that particular pair as AB. So you want these to be always together. So what do? You tie them together. Okay. So they are like one unit. So this one unit and how many remaining fellows? Because total 10, these two are together, so it is 1 remaining 8. So how many people are you? How many people you are having? only you are having, this is 1 unit, remaining 8 people. So let us call them as 8 units. So 8 plus 1, that is 9 units. So number of ways you can arrange 9 units in a row. How many ways you can arrange 9 units in a row? That is 9 factorial ways. 9 units can be arranged in a row in how many ways, sir? 9 factorial ways. But in each of these arrangements, AB are always tied. But you are always getting AB in that given order only. I said AB together, but I ever said that A first, B next? No. So for each of these arrangements, we can arrange AB among themselves. That is, for each of these arrangements, AB can be arranged in how many ways? For each of these arrangements, AB can be arranged among themselves in how many ways? 2 factorial ways. So for each arrangement, there are 2 factorial arrangements are there. So for 9 factorial arrangements, how many arrangements of AB together are there? So the number of arrangements in which AB together is given by 2 factorial into 9 factorial. But I want probability for this. The number of arrangement in which AB, that is certain pair always together, is given by denominator is total, that is 10 factorial. Numerator is favorable, that is nothing but 2 factorial into 9 factorial. So that is nothing but 2 factorial into 9 factorial upon 10 factorial can be written as 10 into 9 factorial. So that is nothing but 2 by 10, yani 1 by 5. So what is the probability that certain pair always together, Babu? It is 1 by 5. Is the idea clear? Hope you understand. See, always remember this idea, sir. Whenever you want 2 members together, 3 members always together, or 4 members always together, in such cases, suppose you want 5 always together. Suppose you want 5 members always together. Suppose let them be A, B, C, D, E. Tie them up. They become 1 unit, remaining 5 units. So what happens? You are having 6 units. First arrange them. 6 units can be arranged in a row in 6 factorial ways. But for each of these arrangements, these 5 people can be arranged among themselves. So number of arrangements of A, B, C, D, E among themselves, that is 5 factorial. So the number of arrangements in which 5 members are always together is given by 6 factorial into 5 factorial. See, this is one of the very interesting idea, Babu. Whenever you want a particular members always together, tie them up, consider them as 1 unit, remaining units plus this unit, you have total number of or total units or total objects, total number of arrangements you are having, you will get some value like 6 factorial in this case. For each of these arrangements, because there is no condition among how many ways you can arrange them, so for each of the arrangements, these 5 members can be arranged among themselves in 5 factorial ways. Just multiply that 6 factorial with this 5 factorial, you get the required answer. So whenever you want 2 members together, 3 members together, 4 members together, consider them as 1 unit plus remaining. 1 unit plus remaining. Am I clear? So this will give you some answer, say K. So there are K factorial arrangements. And in this unit, how many are there? Suppose there are R people. So K factorial into R factorial is your answer. Always remember this idea, my dear friends. Am I clear? This is a wonderful idea. We are using it to solve this problem. Please note that point. Now the same question, but here I want certain pair never together. See here, when you are having only 2 members, see this idea works only for 2 members. For 5 members, this does not work. Please note that point. Okay, please note this point. So we already know probability that certain pair always together. Now the question is certain pair never together. That is, you want this particular pair never together. What is the probability for this? See, either 2 members are together or not together. There is no other possibility. So obviously we go for indirect counting. That is 1 minus probability that the pair always together. And what is the probability that the pair always together? That is 1 by 5. So what is the answer for this? 4 by 5. Don't try to do this for 5-member situation. 5 members never together. Don't do that. That is a complicated situation, Babu. Am I clear? There you need to consider many situations in between, because if you are having two members, either they are together or they are not together. But if you are having three members, they may be together, they are completely separate, two of them together and one is separate, this fellow separate and these two are together, these two are together, this fellow separate. See, this many cases will arise. So you have to remove all these cases to get this answer. Okay, to get this answer from total, you have to remove this case, this case, this case and this case. Then you are going to get the required answer, Babu. Please note this point. Okay, this is a very simplified situation, because two members may be either together or not together, happy situation. But when this problem asks like no two members are together, okay, suppose I am having three members, no two members are together, what is the probability of that? If you want to do it, you have to find probability for this, probability for this, probability for this, and from total you have to remove all these four to get the probability for this. Indirect counting becomes very complicated, sir. Am I clear? So we are not handling this now. We need some more information to handle that. Okay. So first let us solve the basic level problems. Try to fix our ideas. Then we move on to the next level problems. Got it? We try to do it. For that, generally we require the idea of partitioning. Okay. I'll let you know that later on. Now look at this. The same problem which you solved, we can make it general situation. Instead of 10, I may be having n people. Suppose n people are arranged linearly. Let A and B are two among them. What is the probability that A and B are always together? What is the probability that this A and B are always together? Same problem we are generalizing, sir. Instead of for 10 people, we are doing it for n people. So A, B are always together means what? They are like one unit, remaining how many? N minus 2. So n minus 2 plus 1 is n minus 1. So you can arrange those units in n minus 1 factorial. For each of these arrangements, AB can be arranged in how many ways? 2 factorial ways out of total n factorial. And when you simplify, the answer is 2 by n, not n minus 1. 2 by n. Is the idea clear? What is the probability that A and B never together? A and B never together. So for this, the answer is 1 minus AB always together, which is nothing but 1 minus 2 by n, which is n minus 2 by n. And that is the answer. So if you are having 10 people, what is the answer? 2 by 10 for AB together. Suppose you are having 10 people. If you want to use formula method, suppose you are having 10 people. What is probability that certain pair always together? It is 2 by 10. What is the probability that certain pair never together? It is 10 minus 2, that is 8 by 10. Suppose you are having 20 people. Instead of 10, 20 people are there. What is probability that AB always together? That is 2 by 20. What is the probability that AB never together? What is the probability that AB never together? That is nothing but 18 by 20. If you want, you can simplify like 1 by 10 and it is 9 by 10. You can solve many more problems similarly like this. Is the idea clear? Yeah. Now the same story, circular arrangements. 10 people are arranged in circle. So you know, for circular permutation, what is the story we need to remember, sir? Number of ways of arranging n objects in a circle is given by n minus 1 factorial, because we need to fix one object and arranging remaining objects linearly. That is the logic. So what is the probability that A and B are always together when 10 people are arranged in a circle? So here total, first of all let us find out total. 10 people in circle. How many ways you can arrange 10 people in circle? 10 minus 1 factorial, that is 9 factorial ways. Now let us come back to the question. You want certain pair always together. You want certain pair always together. So let us take it as one unit. Remaining how many people? 8 people. So let us call them as 8 units. So total you are having 9 units. Now, how many ways you can arrange 9 units in a circle? 9 units can be arranged in a circle in how many ways? 8 factorial ways. 9 units can be arranged in a circle in 8 factorial ways. Now, for each of these arrangements, see, in each arrangement, AB are already there. So, for each of these arrangements, AB can be arranged in how many ways? Now, people think that AB can be arranged in circle. So, for AB, they feel one fellow need to be fixed, so 1 factorial. Please don't do that, sir. See, AB are among the 9 units. So, in the 9 units, already one object is fixed. So, again for AB, you don't have to fix anything, sir. So, AB can be arranged in 2 factorial ways only. So, the number of arrangements in which AB together is given by 2 factorial into 8 factorial. So, what is the probability that AB together is given by 2 factorial into 8 factorial upon 10 factorial? Sorry, not 10, Babu. Denominator is 9 factorial. Please be careful. Denominator is, total is 9 factorial, na? 9 factorial. So, when you simplify, you are going to get 2 by 9, my dear friends. So, the answer for this is 2 by 9. Now, 10 people are arranged in circle. What is the probability that AB never together? So, you do indirect counting technique for this. Probability that AB never together is given by 1 minus probability that AB are always together, which is 1 minus 2 by 9. And that is nothing but 7 by 9. Now, we can try to generalize this as a result. Suppose you are having n people who are arranged circularly and AB are 2 among them. What is the probability that AB are always together? So, total here is n minus 1 factorial. You want these two members to be together. So, it is 1 unit remaining n minus 2. Okay, n minus 2 plus 1 is n minus 1. How many ways n minus 1 fellows can be arranged in a circular manner? N minus 2 factorial ways. And for each of these, the AB can be arranged among themselves in 2 factorial ways. So, the answer for this is 2 by n minus 1. And what is the probability that AB never together? Which is nothing but probability that AB are always together, and which is nothing but 1 minus 2 by n minus 1, which is nothing but n minus 1 minus 2 by n minus 1, which is n minus 3 by n minus 1. See, my dear friend, this is direct gate question. Probability that AB never together. When you are arranging n people in a circle, what is the probability that certain pair never together? This was a gate question. And you directly answer. What is the answer for that? N minus 3 by n minus 1. See, if you want logically, you can solve it. If you remember the formula, using formula also you can solve. That is the idea. Hope you understand. Now, we already written this formula. Number of R permutations of n objects is given by the formula NPR, and it is nothing but n factorial by n minus R factorial. Now, let us try to use this NPR formula, that is R permutation of n objects. Out of n objects, okay, you want a R permutation. So, you have to select R objects and arrange R objects. So, the idea actually goes like this, Babu. Suppose if you are having n objects and you are making a R permutation. So, it is 1, 2, 3 and so on, R permutation when you are making. So, the first object can be selected from any of these n objects, and the second object can be selected because it is permutations without repetition, because it is permutation without repetition. So, what happened? For the second object, you are having only n minus 1 choices. For the third object, you are having n minus 2 choices. So, for when it is second object, it is n minus 1. Third object, it is n minus 2. When it is rth object, it is n minus r minus 1. So, this is number of R permutations of n objects. Actually, here if you observe, it is n into n minus 1 into n minus 2 and so on. If you observe, if it goes up to 1, it is n factorial. But it is not going up to n factorial. I mean up to 1. So, what I do is, I complete this product. That is the missing terms. What are the missing terms, Babu? N minus r. Okay. Because it is n minus of r minus 1. Next one is n minus r. and so on up to 3 to 1. That is, this extra product which I actually given here is nothing but n minus r into n minus r. Okay, so it is n minus r plus 1, n minus r minus 1, and it goes up to 3 to 1. So if you see now, the numerator is n factorial, denominator is n minus r factorial. So this is the formula for your NPR bubble. This is the formula for your NPR, which is n factorial by n minus r factorial. Okay. So now let us use this to solve the following problem. See here, I just given it as dogs and cats. Instead of dogs and cats, you may find problems like male and female, boys and girls, okay, dogs and cows, okay, monkeys and donkeys, anything it can be. Okay, some people also may give consonants and vowels. Different combinations may be there, sir. The logic is same. Okay, you have one category of this type, second category. See how I always see this as category 1 and I see this as second category. They may be dogs and cats, or they may be numbers, okay, vowels, consonant vowels, they may be monkeys, donkeys, it does not matter for me. There are 5 of category 1, there are 4 of category 2. Try to understand. See, if you just solve dogs and cats, you will be having only dogs and cats. But if you see the logic behind it, you can handle any such kind of problems where you are having 5 of one category, 4 of second category. Try to understand that generalization. Then any such problem when they ask, you don't find difference. Okay, so these numbers may change, but what we need to understand, we are having some objects of category 1, some objects of category 2. That is the logic. If you understand, any such problem is not at all a difficult one. Please note that point, my dear friend. So we just need to understand that we are having 5 of category 1 and 4 of category 2. Always understand logic. So first let us try to handle this dogs and cats. Later on, instead of dogs and cats, you can keep different things and try the problem. Same thing. There are, suppose 5 dogs and 4 cats are arranged linearly. Okay. Then find probability that the 4 cats are together. So first of all, total. What is the total, sir? We are having 5 dogs and 4 cats. Okay. So total is what, sir? We are totally arranging 5 plus 4, 9 units. 5 dogs and 4 cats are arranged in a line. How many ways you can arrange 5 dogs and 4 cats in a line, sir? It does not matter whether they are dogs or cats, sir. Total there are 9 units. How many ways you can arrange 9 units in a line? 9 factorial ways without any restriction. But here we are having a restriction. The 4 cats together. In the first question, we want 4 cats together. So this is 1 unit. And the remaining 5 dogs are 5 units. So total we are having 6 units. So these 6 units you are arranging in a line. So the number of arrangements are 6 factorial, because in line 6 units can be arranged in 6 factorial. And for this, each of these 6 arrangement, that is 1, 2, 3 and so on, 6 arrangement, for each arrangement, because in each arrangement the 4 cats are there, but there is no restriction that which cat should be first, which cat should be second. So for each of these arrangements, the 4 cats can be arranged among themselves. So for each of these 6 factorial arrangements, the 4 cats can be arranged among themselves in how many ways? 4 factorial. That is, for one arrangement there are 4 factorial are there. For 6 factorial, how many arrangements should be there? 6 factorial into 4 factorial. So the number of arrangements in which 4 cats together is given by 6 factorial into 4 factorial. So what is the probability that the 4 cats together, total is 9 factorial, that is in the denominator, and in the numerator favorable, that is 6 factorial into 4 factorial. Simplify to get the required answer. Simplification is not my work, sir. Please try to do it. Is the idea clear? Those who are trying or solving together, please try to give the answer, sir. Is the idea clear? So what is probability that 4 cats are together? This one. If you want, you can simplify, sir. So here 6 factorial cancels. So what is remaining here? 9 into 8 into 7 will remain. So 4 factorial, that is 4 into 3 into 2 into 1. So 4 2's 8 gone. So 3 3's. So 1 by 21. That is the required answer. Simplification is your wish, sir. Okay. Of course, your wish in the sense, if you are writing an examination, there simplification is expected, you have to do it. Here, for this situation, your wish, you can continue further. Now this one is very interesting. No 2 cats are together. I told you this idea. So when you are having 4 cats, cat 1, cat 2, cat 3, cat 4. Actually, all the 4 cats can be together. All 4 cats can be together. No 2 cats together. Okay. 3 cats may be together and 1 is separate. Any 3 cats together and 1 is separate. 2 together. 2 together. Of course, even here C1, C2 you may have C1, C3, C2. The idea is 2 together, 2 together. You may have 2 together and 2 separately. Okay. Or no 2 of them together. All of them separately. So these are all different combinations. So don't write this way. I think this create, a little confusion, because you may fix like, only C2, C3 together. So I'll just show you this. Just say it like this. So we are having 4 cats together. All 4 of them together. 3 cats together and 1 cat separate. 2 cats together and 2 cats together. 2 cats together, 1 cat separately and 1 cat separately. And all the 4 cats separate. So the last situation is what is called as no 2 cats together. That is what we call it as no 2 cats together. So if you want to try this indirectly, it is a bomb blast. Because from total you have to remove this, you have to remove this, you have to remove this, you have to remove this. But these things cannot be solved very easily. This is fine, we can do it, we already know the answer, but these are involved because you need to understand the partitioning concept to handle these problems. If you want 3 cats together and 1 separate, 2 cats together, 2 cats together, this kind of situations, if you want to solve it, generally people never answer them. Okay, why? Because if you need to solve this, you should understand the concept of partitioning. Okay, I'll try to discuss that concept also. Okay, maybe in a simple manner tomorrow. Okay, if time permits. Okay, generally for computer science students under combinatorics, I definitely do this concept. Okay, where permutations with constrained repetition, we get this partition concepts. Okay, please note that. So this method doesn't work here. So what is the idea? How we are going to solve it? No 2 cats together. So here, who are not having any restriction? Who are not having any restriction in this case? We are having cats and dogs now. There is a restriction on cats. Who are not having any restrictions? Dogs do not have any restriction. So first arrange them. So we are having 5 dogs. Okay. So 5 dogs can be arranged in a line in how many ways? 5 factorial. Why we are arranging dogs first? Because there is no restriction on them. So first arrange the category which do not have any restriction. So 5 dogs can be arranged in a line in 5 factorial ways. So here it may be something like this. So you may have dog 1, dog 2, dog 3, dog 4, dog 5. What is that you want? No 2 cats together. If you see, you can find some gaps. You can find some gaps. If you arrange the cats in the gaps, because obviously other than the gaps, remaining all dogs are there. So if you arrange the cats in the gaps, obviously no 2 cats will be together. How many gaps are there? 1, 2, 3, 4, 5, 6. Note, whenever there are n objects in a line, there are n plus 1 gaps. So here we are having 5 dogs. So how many gaps are there? 6 gaps. So you arrange cats in this 6 gaps. So you arrange the cats in this 6 gaps. How many cats we are having? 4 cats. So arrange 4 cats in 6 gaps. So that can be done in how many ways? 6p4. See, for each arrangement of dog, there are 5 factorial arrangements of the dogs. 1, 2, 3 and so on. 5 factorial arrangements of the dogs are there. For each arrangement of the dog, the cats can be arranged in 6p4 ways. For each arrangement, there are 6p4 arrangements of cats are there. Therefore, for 5 factorial arrangements, how many arrangements were there? 5 factorial into 6p4. So the number of arrangements in which no 2 cats together, the number of arrangements in which no 2 cats are together is given by 5 factorial into 6p4. Is the idea clear? So what is the probability that no 2 cats are together? What is the probability that no 2 cats are together? Denominator is total, that is 9 factorial. Numerator is 5 factorial into 6p4. And that is the required answer, Babu. That is the required answer. Hope you understand. Simplify to get the required answer. So please try to understand this, Babu. Whenever you are having category 1, category 2. Okay. So you may be having any number of cases. Okay, here you may have 6 and here you may have 7. So total will be what, sir? Total will be what? 6 plus 7, 13 factorial arrangements. Suppose you want 6 category 1 together. You want category 1 together. So it is 1 unit plus 7. 1 plus 7, 8 factorial into category 1 factorial, that is 6 factorial. So what is the probability for this? Divided by 13 factorial. Suppose you want category 2 together. Suppose you want category 2 together. This is 7, 1 unit plus 6. 6 plus 1, 7. 7 factorial. For each of that, this category 2 can be arranged among themselves in 7 factorial ways out of total, that is 13 factorial. Now suppose if I want no category 1 together. No category 1 together. So who are not having any restriction? Category 2 are not having restriction. Arrange them. 7 factorial. 7 means how many gaps? 8 gaps. In the 8 gaps, how many you need to arrange? 6 you need to arrange. That can be done in 8p6 ways out of total. Suppose if I ask probability that no 2 category 2 together. No 2 category 2 together. So denominator is 13 factorial. So category 2 together means restriction on category 2. So category 1 are not having any restriction. So they can be arranged in 6 factorial ways. But how many gaps are there? 7 gaps. 7 gaps you need to arrange 7. That can be done in 7 factorial ways. See, sometimes you may be having 7 gaps but you need to arrange 8. That is wrong. In such case, that arrangement is not possible. Because if you are having more objects than the gaps, obviously that condition will be violated. So please note that point, my dear friend. Always remember that. Okay. So you can take this number, you can change these numbers, sir. You keep on changing these numbers, we can still solve the problems. Okay. So what I want you to try is try to change these numbers and keep on solving it. And always remember the cases where there is a violation in the condition. Okay. For example, let us keep here 5 and here 8. Okay. 5 and 8. So total is 13. That is total 13 factorial. Category 1 together. Category 1 together means they are like 1 unit. You can arrange them together. 1 plus 8, 9 factorial. Total 13 factorial. Suppose you want category 2 together. This is 1 unit. 1 plus 5, that is 6 factorial. And these people can be arranged among themselves in 8 factorial ways out of 13. Now look at this. No category 1 together. You don't want category 1 together. So who are not having any restriction? Category 2 are not having any restriction. Arrange them. How many gaps? 9 gaps. You need to arrange 5. That can be done. That is 9p5 out of 13 factorial. But look at this now. Look at this now. no category 2 together. So these are not having any restriction. You can arrange them in 5 factorial ways, but there are only 6 gaps. How can you arrange 8 in 6 gaps? It is not possible. So the probability for this is 0. Not possible, impossible event. So probability for this is 0. It is not possible at all. So once you understand whether it is cat, dog, men, women, boys, girls, monkeys, donkeys, it does not matter. Okay, consonant, vowels, it does not matter. You can always handle this. You can always handle this. Am I clear? This is a very, very important concept, Babu. If you understand, okay, always remember this. When you are having category 1, category 2, two easiest problems which they can ask you is all together, no 2 of them together. But if you are asking a question like 3 of them together, suppose you are having 4 here and 5 here, suppose cats. Okay, so 4 cats may be together, 3 cats together and 1 cat together, 2 cats together, 2 cats together, 2 cats together, 1 cat together, 1 cat together, and no 2 cats together. So out of these, which problems are easier to solve, Babu? This one and this one we can solve it very, very straightforward, very easily. For these problems, you need the concept of partition. With the concept of partitioning, you can solve that problem. Please note. Am I clear? Directly, difficult to handle them. Maybe small numbers you may handle, but please remember to solve that we need to understand the concept of partitioning. Am I clear? That is permutations with constrained repetition case. We handle such problems, my dear friends. Hope you understand. Is the idea clear? Like that. Same story now. For I think I haven't taken this for. Okay, you can try this. Okay, I think I missed the problems for circular permutations. So, I have one question for you. Same problem, this third end. Instead of this linearly, I want you to try this circular. You can try this. So, this problem you need to solve it circularly, that is homework. Try this circularly. Even this, you need to try in the case of circular permutation. Try this circularly. So tomorrow I am going to give you the solutions for those 2 problems. Please remind me, my dear friends. Now R combination of n objects. R combination of n objects. Actually, we already know that NPR is nothing but what? Selection followed by arrangement. So if you want, what is NCR from this? That is NPR upon R factorial. And what is NPR, Babu? N factorial by n minus R factorial. So it is n factorial, R factorial is already there in the denominator. NPR is nothing but n factorial by n minus R factorial. So that is the formula for NCR, my dear friends. That is the formula for NCR, which is n factorial by R factorial into n minus R factorial. Very important. Of course, here I just given. Let me remove this. That is the derivation which I given. Because this derivation comes from the idea that NPR is equal to NCR into R factorial. This is the first step, this is the second step, and this is the third step. And that is how we get this particular formula. Is the idea clear? And there are some general formulas which I already mentioned. NPR is nothing but selection followed by arrangement. So first select R objects, then arrange the R objects. Is the idea clear? NCR from this can be obtained like NPR by R factorial. I think I already given that anyhow. Now this is very interesting. Now you are having n objects. How can you select 0 objects? Out of n objects, how can you select 0 objects? You don't select it, na? That is the only way. How can you select 0 objects? You don't select anything. That is one way. That is the answer. So this is, combinatorial reasoning we call it. Okay. Logically we are giving the answer for that. Now you are having n chocolates or 10 chocolates. How can you select 10 chocolates? Select all of them. That is the only way. So answer is 1. So if you are selecting 0 out of n objects, the only way is don't select it. That is the one answer. If you want to select n out of n objects, how can you do it? Select all of them. That is the only way. So 1 is the answer for that. So answer for these two is 1 using combinatorial reasoning. NCR is equal to NC n minus R. So for this, we are having one very good reasoning. Suppose I am having 10 chocolates. Okay. And I ask you to select 4 chocolates. So I am having 10 chocolates and I ask you to select 4 chocolates. You selected 4 chocolates. Automatically, the remaining 6 chocolates are selected for rejection. So whenever you selected 4, remaining 6 are selected for rejection. So similarly, when you selected R objects for accepting, automatically remaining n minus R objects are selected for rejection. So selecting R object is equivalent to rejecting n minus R objects. So out of n object, if you are selecting R objects, means it is equivalent to rejecting remaining n minus R objects. So the number of R combination of n object value is exactly same as number of n minus R combination of n objects. That is the formula. Now this is about, combination problems. Okay. Suppose a committee of 5 is formed from, again here also, this is category 1 and this is category 2. Here I am using boys, girls. You may have men, women. Okay. You may have monkeys, donkeys, anything. Consonants, vowels, any 2 categories, sir. It does not matter. It is category 1 and it is category 2. Just try to understand that way. Suppose a committee of 5 is formed, that is selected from 6 boys and 7 girls. What is the probability that the committee has exactly 4 girls? Okay. First of all, let us try to do this selection, sir. Okay. How many ways you can select 5 out of 6 boys and 7 girls? Total. First of all, let us see that total. I think I'm having a diagram here. Let me check that. Okay, not here, in the next page, no problem. First of all, let us see the total. How can you select 5 members? Selection or forming, does not matter. From 6 boys and 7 girls. How can you do it, sir? It can be done in, because total there are 13 members are there. From that you are selecting 5. That is the number of ways we can select 5 members out of 6 boys and 7 girls. Okay, 6 plus 7, 13, correct. Okay, 13C5. But I want you to understand this carefully, sir. If you are selecting 5 from 6 boys and 7 girls, the possibilities are, you may select all the 5 boys and you not select any girl, or that is the 5 selection can be done. The 5 selection can be done in only one of the following, I clearly say, disjoint ways. The 5 selection which I make can happen only in one of the following ways which I am showing. That is, the 5 selection can be done like this. I may select 5 boys and 0 girls. You may call me unfair, that does not matter. I just need to select 5 members. So I select 5 boys and 0 girls. Or I may select 4 boys and 1 girl. Or I may select 3 boys and 2 girls. Or I may select 2 boys and 3 girls. Or I may select 1 boy and 4 girls. Or I may select 0 boys and 5 girls. See, these are the 6 different ways and only ways in which I can make this 5 selection. Please understand this, Babu. It is very important. I know people mess up with this combination problems. Okay, it is being happening from years. Okay, hundreds of years, but still this particular confusion always exists. Because of that, I am making a very, very solid statement here. The 5 selection which you do can happen. The 5 selection which you do can happen in only one of the 6 disjoint ways which I given here. There is no other way in which you can make a phi selection. Can you do it like this? 2.5 men and 2.5 women can be selected. It is illogical. Am I clear? It is illegal. It is not possible like that. You want to make a phi selection means the number of boys and number of girls which you select must be an integer. Positive integer value or non-negative integer value it is. Am I clear? So only these are the ways in which you can make that phi selection. Now let us see each of them. How can you make this selection? Here clearly selecting 5 out of 6 boys. How can you select 5 out of 6 boys? 6C5 ways followed by 0 out of 7 girls can be done in 7C0 ways. So this first type of selection, okay, the first type of selection can be done in 6C5 into 7C0 ways. How can you do this second type of selection? Selecting 4 out of 6 boys, that is 6C4 into 7C1. How can you make this third type of selection? 6C3 into 7C2. How can you make this fourth type of selection? 6C2 into 7C3. How can you make this fifth type of selection? 6C1 into 7C4. And how can you make this sixth type of selection? 6C0, that is selecting 0 out of 6 boys followed by selecting 5 out of 7 girls. So this, if you add, can you tell me what is the answer for this? Can you tell me if you add up what is the answer we are going to get? Anyone? Please try to answer. If you add up, that answer is 13C5. Those who understand this logic never ever do mistake with combination problem. This is the heart of combination problem, Babu. This is the heart idea behind this. जिसको ये समझ में आया कभी गलती नहीं होगा. Never ever do mistake in this. Take it as my word. Am I clear? This is the idea. This 13C5 which I given here, that can happen in one of the 6 ways. And if you add all of them, you're going to get 13C5. So this 13C5 is actually sum of all these 6 different or disjoint ways. Adding them, you're going to get the answer 13C5. So in this problem, that 13C5 can happen only in this way. That 13C5 can happen only in this way. Please note this point, Babu. All of you. Is the idea clear? Clear? Now, okay, we haven't solved actual question here. What is the actual question? What is the probability that the committee has exactly 4 girls? But now, what is the question in this problem, sir? There is a question here. We haven't solved that. Let me answer, solve that question. What is the probability that the committee has exactly 4 girls? See, exactly 4 girls means which situation? This is the situation. So this is the favorable and this is the total. So what is the answer? Favorable by total. That is 6C1 into 7C4 upon 13C5. And that is your answer. So what is the probability that the committee has exactly 4 girls? 6C1 into 7C4 upon 13C5. Now the next question. Committee has at least 2 girls. So this is always fixed. At least 2 girls means what, sir? At least 2 girls means what, sir? 2 or more girls. So these are the 4 cases. So these are the favorable cases. And you know what is the answer for each of them? This is 6C5 because 6 boys and 7 girls are there. 6C5 into 7C0. 6C4 into 7C1. 6C3 into 7C2. 6C2 into 7C3. So what is the probability? This is favorable. Denominator we already know 13C5, that is total. Favorable is, this is direct method. I also have an indirect method for this. I am also having an indirect method for this. So what is it? 6C5 into 7C0. 6C4 into 7C1. 6C3 into 7C2. 6C2 into 7C. Direct way. But there is one more way. We can also handle this problem indirect way or indirectly. So what is that you want? Probability that the committee has at least 2. So why to write entire story? Let me just write that important statement. Committee, we already talking about committee, at least 2 girls. So whenever you want at least 2 girls, from 1 minus you can do at most 1 girl. So that is from total, if you remove these 2, you are going to get the remaining. So that is at most. What is it? It is, see, this is at least 2 girls. And what about this? This is nothing but at most. See, whenever it is at least 2, the opposite of this is at most 2 minus 1. That is 1 girl. At most 1 girl. And that is it. So what is the answer for this, sir? 1 minus, this is 13C5 in the denominator, numerator, these 2 fellows. This is nothing but what, sir? 6C1 into 7C4, and this is 6C0 into 7C5. So it is 6C1 into 7C4, and this is 6C0 into 7C5. So simplifying, you are going to get the required answer, Babu. Am I clear? All of you able to follow? So that is the idea for such problems. So now here I can ask you question. See, it is all about, we have these categories. Based on this, he can ask you any question. When you are having number of boys greater than number of girls, 5 is greater than 0, fine. 4 is greater than 1 is fine. 3 greater than, these 3 cases. That is, this problem is same as probability that number of boys greater than or equal to 3. You can directly solve it. Denominator 13C5. Numerator, this case. What is this case? 6C5 into 7C0. What is this case? 6C4 into 7C1. What is this case? 6C3 into 7C2. Simplify to get the required answer. Am I clear? So please try such problem, any such different questions they can ask you, sir. I'll just give you a few more questions for practice. What is the probability that the committee has at most 1 boy? Try these questions. I can also ask at least 2 girls and at least 1 boy. See, at least 2 girls means what, sir? At least 2 girls means 2 or more girls. I think earlier also I made a mistake. Oh, I think at least 2 girls. Oh, I think here I made a blunder. Sorry for that. For boys I done. So let me change this as boys then. Sorry, I thought this is girls. So please excuse me for that, sir. It was a blunder. I was and haven't seen that. Okay. This was at least 2 girls means this categories I have to consider actually. Okay. Sorry, there was a blunder here. Please change this question as boys, my dear friends. Sorry for that. Okay. Please check that. Please be careful, because if you not seen properly, that is a blunder. That is a big blunder which I done there. Okay. Please note that. You can ask any question. At least 2 girls. 2 girls means what, sir? 2 or more this side, and at least 1 boy, 1 or more this side. So common part, what is the common part for this? At least 2 and at least 2 is this, and at least 1 is this. Common part is what? this one, these three cases. Okay, and this problem, please correct it. I actually solved it for boys, my dear friends. Please correct it. Okay, if you have any doubt, you can ask me. Is the idea clear? Sorry for that. Yeah. Right. So we stop it today here. We'll take up some more problems. Okay, and we also see the other two categories like permutations with repetitions, combinations with repetitions, and permutations with constraint repetitions tomorrow 9 p.m. Okay, so if you have any issues or any doubts, you can ask me. Try this problem as a homework. So if you get answers, so answers you can write in the chat box, my dear friend, or in the comment section. Please share this session with your friends so that they also get benefit out of it. So I'll be doing the entire probability. Okay, here I am doing probability and statistics part 1. It is for all branches. It is for all branches. Hi sir, programming wala. Hello sir, I am your student. Thank you programming wala. After how many days you are seeing me? Okay, please do attend and also inform your friends so that they can get the benefit out of it. Okay, so I'll be coming regularly, and also Sudhakar Reddy sir is taking DBMS. Let us try. See, the main agenda is DA only, data science and artificial intelligence. Me and Sudhakar Reddy sir, okay, will be completing this entire sessions. Okay, here as well as in my app. Okay, in app you also get some other additional material. You are in paid batch. Okay, very good sir. So the paid batch, I think it is recorded versions. So now we started some live sessions here. Okay, DA I haven't started sir. DA I haven't started. Good, you are following it. See, the recorded version, it is done in a very proper manner, because the questions, some more additional questions you may find there. Okay, and those who are interested can attend my classes regularly. This is a very interesting problem. Tomorrow we'll try to see this. Okay, see, because when it is a paid with MACSGATE app, you can take subscription even for 1 day. 1 day subscription. Okay, I think for mathematics it is 15 rupees for 1 day subscription. You are also having 1 day subscription. The idea is, suppose you are preparing for 10 days. It's not necessary that all the 10 days you continuously prepare. You may do 2 days, then you may take 5 days break, again you may do 5 more days. So whenever you are preparing, then only you can subscribe and get the content, my dear friends. Okay, of course all this recorded content, all this live content also I'll try to update in the MACSGATE app. In the MACSGATE app, what you are having all the P by Qs, sorted manner we solved. So you find all the P by Qs in a very sorted manner, topic wise they are given. For example, here, you can do it at your own pace, my dear friend. Okay, so the agenda is ₹15. So what I want, suppose generally mathematics you can complete in 10 days properly if you do it. So 150 rupees you get the entire mathematics. Those who want entire year, you can purchase. I kept it for 1,000 rupees or something. It is there. It is available. Okay. Those who are wanting for 1 day, you can take it. 3 days also I given. Then I given for 3 months, and 1 year subscriptions I given. So we are having different subscriptions. Those who are interested can take those subscriptions, sir. I'll try to update all the other content, because the only advantage with MACSGATE app is you also have P by Qs and practice questions. We are updating this. See, I am not going to update this practice questions like daily practice problem. This is all nonsense. I am not at all interested. So daily, suppose there are 10 subjects, daily I give you problems from every subject. It is like making a mess up the entire study, sir. Okay, understand the concepts, try to solve previous year questions, some practice questions from any book you take. I suggest standard books for mathematics. For mathematics, always take standard book, good for health. Thank you, programming wala, for attending this session also, and for everyone those who are attending this session. So daily I'm coming up with this session 9 o'clock daily, 9 p.m. I'm planning. So I thought earlier I come up a little earlier, but at 7 o'clock alternative days, every alternate days we are having DBMS by Sudhakar Reddy sir. So he is one of the champion, okay, and without any preparation he got 200 rank in GATE data science last year. No preparation, directly went and he returned, and he just attempted and he got 200 rank, okay. And he mentioned that he not even prepared or not even opened the topic of artificial intelligence. He left some topics, still he could able to get 200 rank. So what he is giving you a very good detailed DBMS topic with all the previous year questions solved, and you can enjoy. So it's like, you know, you will not have, see here what I am speaking is unnecessary information, okay. Those who are interested can, because it is not a subject information, what generally people call it as motivation, okay. But if you see the Sudhakar Reddy sir class, he start with the concept, problems, properly all the PYQs are solved, all the concepts are covered, how much is required, only that much. Even I am doing the same thing, sir, with my subject. I'll not unnecessarily do the problems to trouble you. And when you are preparing for your GATE examination, Babu, please don't open your IIT JEE knowledge. If you are interested, you want to do it. But that doesn't help here. This is application stage. IIT JEE is learning stage. Okay. Without understanding, okay, just dumping, you know, the preparation with problems doesn't help anyone. I am very clear. I am clear with this thought from last 15 years where I am very, very seriously devoted to GATE coaching. Okay. This information I already passed even with my, leader in one of the organization when they asked, like, you know, why you are saying this probability calculus linear algebra is different from probability calculus and linear algebra in IIT JEE. I very clearly mentioned that is learning stage. This is application stage. Don't unnecessarily mess up with this. I am having 22 years of teaching experience in this. I can compulsorily clearly tell this to anyone, whoever it is. I am ready to debate also. Okay. So you need to understand at this level what you need to prepare. Okay. Just dumping all the problems in the world. So you are not in a learning stage. Try to understand. That's a common sense thing, sir. Okay, I do for probability for 100 hours, so I can do for 100 hours, 200 hours, 400 hours also. Okay, you solve every damn problem in the world, it doesn't make any sense, my dear friends. Even here I am doing little extra only because you are having this probability part even in your aptitude. So it may be helpful for that. Generally for GATE level, the concepts which they can ask you more from conditional probability onwards. Sometimes they also ask you basic questions like from addition theorem, even that they can ask you. But nowadays you can get these questions from your aptitude. Please try to understand you are preparing for which examination, prepare for that. Okay. Just to prove my knowledge, what I know, I dump the information. It is of no use for the students. Wherever you are learning, understand this. Okay. Some people don't understand my way of teaching. Very good. You should not attend my class at all. You should attend the session where your frequency matches with the teacher. There you learn, no problem. But always try to see your limitation. Am I clear? In the GATE examination, there are around 10 to 12 subjects you need to prepare, Babu. Okay. Each subject, if you try to take their, prerequisites and all, you keep on studying all that, you cannot even qualify the examination. Because of this nonsense only, many of the people are not even qualifying. Qualification is very simple, but people are not qualifying because of this nonsense. So they attend one particular topic, probability they do it for their lifetime. It won't work like that, sir. There need to be a proper methodology which you need to follow to crack this examination. Okay, that's all for today. If you have any doubts, you can ask me. Otherwise, that's all.